You know, the ground beneath your feet feels pretty solid, right? Well, surprise, it's not. It's actually a restless surface, and it's constantly on the move. So today, we're going to dive into the massive hidden forces that build mountains, trigger earthquakes, and literally shape our entire world, plate boundaries.
Have you ever stopped to wonder, why do some places get these massive mountain ranges, while other parts of the world get shaken by violent earthquakes? Well, that's the big mystery we're going to solve right now.
So, the answer? It all comes down to the boundaries of Earth's tectonic plates. The best way to think about it is that our planet's crust isn't a solid shell. It's more like a cracked eggshell, made up of these enormous, moving pieces. And get this, it's right here where these pieces meet that pretty much all of the planet's major action, earthquakes, volcanoes, you name it, actually happens.
Okay, so there are basically three main ways these plates interact. We're going to start with the first type, the planet's great creators. I like to call them the builders.
So, what is a divergent boundary? It's pretty simple, actually. It's just a place where two of these plates are pulling apart from each other. Think of it like a zone of construction, a geological factory where brand new crust is being born 24/7.
And check this out. This image shows the process perfectly. You can see the two plates of the rigid outer layer, the lithosphere, pulling apart. As they do, that allows all this hot, molten rock from the softer layer below to rise up and fill the gap. When it cools, bam! You've got new oceanic crust. It's literally like a conveyor belt for the planet's surface, constantly churning out new ground.
Now these spreading sites, they're not just some small cracks on the ocean floor. No way. They form these enormous underwater mountain ranges called mid-oceanic ridges. The most famous one is the Mid-Atlantic Ridge. It's this huge chain of volcanoes snaking right down the middle of the Atlantic Ocean, and it's constantly building new seafloor.
So how fast is all this happening? Get this, the American and Eurasian plates are separating at about 2 centimeters a year. Yeah, that's roughly the same speed your fingernails grow. It sounds incredibly slow, I know, but over millions and millions of years, that's more than enough to create an entire ocean.
Now, if we're creating new crust in some places, it has to be going away somewhere else, right? I mean, the planet isn't getting bigger. Of course. So let's move on to our second boundary type, the powerful force of destruction, the destroyers.
A convergent boundary is pretty much the exact opposite of what we just saw. Here, two plates are pushing directly into each other. It's a head-on collision. And when they smash together, one plate is forced to dive down underneath the other, back into the mantle. We call this a subduction zone.
In this diagram right here, it shows that slow-motion crash in action. See how the oceanic plate on the left is diving under the other one? That's because it's made of older, cooler rock, which means it's denser, it's heavier, so it just sinks, getting recycled back into the hot mantle. This process is what creates those incredibly deep oceanic trenches, some of the deepest spots on the entire planet.
But here's where it gets really interesting. What happens in these collisions totally depends on what is colliding. When a heavy oceanic plate dives under a lighter continental plate, you get massive volcanoes on land. When two oceanic plates meet, the older, denser one sinks and creates these beautiful chains of volcanic islands. But when two continental plates collide, well, neither one wants to sink. So they've got nowhere to go but up, crumpling and forming gigantic mountain ranges like the Himalayas.
So let's just break this down. It's a tale of two boundaries, right? You've got your divergent boundaries, the builders. They create crust as plates pull apart, and they form ridges and valleys. Then you have the convergent boundaries, the destroyers. They destroy crust as plates push together, and that's how we get mountains and deep ocean trenches. It's this perfect, powerful balance of creation and destruction.
Okay, so we've got pulling apart and we've got crashing together. But what if they don't do either of those things? What if they just slide past each other? Well, that brings us to our third and final type, the sliders. At a transform boundary, the plates are just grinding past each other, side by side, like two cars scraping against each other. So here, crust isn't being made and it's not being destroyed. Instead, what you get is an immense amount of stress and tension building up along that fault line. And you can just feel the tension in this image, can't you? The plates are trying to slide, but they get locked up by friction. So the stress just builds and builds and builds for years, decades, sometimes even centuries, until finally the pressure is just too much. Snap! The rock fractures, the plates lurch forward, and all that stored up energy is released in an instant. And that, my friends, is an earthquake. Okay, let's zoom out. We've met our builders, our destroyers, and our sliders.
How does this all fit together to actually shape our world?
And here it is. This is the whole engine of our planet in one shot. You can see how this system is completely interconnected. For example, you have a divergent boundary, our builder, creating new crust. That crust spreads out until it hits a convergent boundary, our destroyer, where it gets recycled. And connecting these segments, you often have transform faults, our sliders. It's one single, dynamic, global engine that's always working.
So what's the bottom line here? The most important thing to remember is that the Earth is alive. The surface we live on isn't some fixed, permanent thing. Not at all. It's a constantly shifting, incredibly powerful puzzle of interlocking pieces, all driven by the immense heat from the planet's core.
And that leaves us with a really cool question to think about. Since we know these plates are still moving at about the same speed your fingernails grow, what do you think our planet is going to look like in the deep future, say 100 million years from now? What new oceans will open up? What continents will collide? The world that we know, it's just a single frame in a very, very long movie.